YouTube up and running. There we go. Alright, let's get some music running too. Alright. There we go. So today, it's been a while. It has been a while since my last stream. Wow. Anyway, what we are looking at today is the current route that I'm trying to go for scripting. I think this one's actually an achievable one. So in the past, we've made JIT compilation things from scratch. We tried using LLVM. We tried using LLVM to compile Rust. And now, I think I've finally settled on probably the most sustainable solution, which is to compile Rust to WebAssembly, and then load out with a robust WebAssembly runtime that also supports ahead of time compilation. So I have tests of most of what I'm doing, but most of the framework for what I need to actually add this into the engine, we just need to do a fair bit of disconnecting work. I need to do a link to Twitch. I need to actually announce this stream. Alright, that takes care of my streamer needs of posting to social media and all that. Okay, to explain what we're doing, I just have this. So this is in the actual BraneEngine. Oh, maybe? Which one might not be the done? I'm hearing myself talk. Oh, it's Discord. Just playing one of the YouTube replays of one of my other streams. Wow. Alright, back to what I was saying. This is all in the BraneEngine repo right now. And I've just spun up a separate branch where we're testing out using Rust as a scripting language. And we have an executable here, WASM scripting tests. What this does is we're using this library called Wasmer, which is actually originally written in Rust, which is interesting. So it should theoretically be a very robust library. But that's what we're using to actually load the WebAssembly. So just load file, and then what I was doing at the moment, and I can actually show this, I think. Build open Wasm file. So let me just copy that over so we have something to... That's interesting. The Wasm crate does exist there, it's just not showing up. Oh, it's going to the Wasm tests folder. Oh, because they changed stuff. Alright. Change stuff on the laptop. To copy this. Well, test scripts. Target. We're running this. There we go. Don't know why the regular crate isn't working. Because I do have the tool chain, at least for this crate, set to Wasm. Good thing to check. Dynamic lib, Boston crate, path. Maybe there's something I don't understand about a toolchain file. Mustache toolchain. Cool. Do I just say components? These term property must be specified. Channel property. that's just... That's what we want. Just components to install. I'll throw this over here so you guys can see what I'm looking at as well. We're just looking at the all the stuff for this. If we don't say specifically that, and we go to here, we say cargo build. First we get warnings because my scripts are kind of messy. But it doesn't build a bottom target. Even though our tool chain said it's specifically built for that. We name the project's directory Rust tool chain. Let's try this. What if we delete the tool chain in here? Say rust override set. What's it? Lost in 32. It is lost in 3. Alright. think that's what I'm looking for. Overwritten by that. So this overwritten by something else. So Linux is the current active toolchain. That's the default. Okay, that should show up better on the screen now. Hello, how's it going? Long time no see. We are using stable. How do I know that it's using... Wait a second. So this overrides specifically which one of the toolchains we're using, but not which one of the targets. Cargo, force, shuttle, change default. It does? All of it, or just like the background or mic? It's saying my bitrate is decent. Like laggy? Okay. we're going into settings, sound, input. It's either this one or this one. So Realtek. Okay, so it is that correct microphone. Let's check OBS. Output, audio. And turn the monitor off. It's on all tracks. Is it still doing the weird thing where if it's not mono, it sounds super bad? Doesn't look like it is. Alright, so I can actually turn mono off. So, Alright, testing audio now. Does this sound decent? Okay, we're good. I just pressed random things and hopefully that fixed something behind the scenes. But yeah. Before, it looks like we can add build.target to this. So instead of having a toolchain file here, you can actually say build and then target. And let's try building this. Okay, so we're still not, for some reason, we're not building to WASM. Maybe it, oh, this is in config. No, it's not. Cargo config. So yeah, this is in cargo config instead of the package. Well, I guess I just have to deal with always passing the command line argument. RIP. Cargo build target. Well, actually, I have the sh script. So let's just run that. And now we have our WASM built. Let's copy this over. Well, actually, if I run CMake, it should copy it over for me. Yep, it does. Okay, so that's all working as intended. We just can't get it to build WASM by default. Okay, so now that we actually have that built, I can show you what the test loader does. It goes and it shows all the stuff exported by this all the stuff exported by the WASM binary, and also attempts to call a function. In this case, I think it's trying to call this as a function because I just say export whatever. I'm not actually checking what they are, and that's what we need to, one of the things we need to work on. So yeah. So yeah, the second extern in the list. So we're calling this as a function, which obviously we shouldn't be doing. And I did have like it calling the function everything before. Let me edit the Rust files real fast so that they will actually show up in this WASM binary. Let's go test script 1. And what we do here is this needs to be no mangle, and also extern C. Actually, let's do it for function. There we go. So this is the file signature we need for a, not file, function signature we need for something to actually show up in a WASM binary. So if I run compile script sh now, we rerun CMake to copy the binary over. Now, when we run scripting tests, you can see test function returned 42, and it also shows up in the list of exported functions. And we could even go a little bit more in depth, like ret I32. We'll just return like that. Let's change up our scripting tests. Let's have one arg. Awesome int val. Uh, 32. How does this work? I'm not actually sure how to set how to set actual values. So WASM, oh, I32 value, is this what I want? Oh, init value, not int value. So we don't want init value, we want I32 val. And then that gets passed into our function call. So let's recompile this script. Rerun cmake. Oh no, it appears everything has broken. Oh, it's because we're no longer on the build target. There we go. So this should say, yep, 32. So that's actually the value that we're passing in, so we could change this to whatever we want it to be. Like, let's do 69 for the fun of it. And there we go, it returned 69. So we have Rust. We have a way to compile it to something that we can load into the game engine. And furthermore, this WASM runtime has support for WASMer. It has Brane. Come on. I'm looking for the actual docs. There we go. So it has several different like backends for how much we want to optimize stuff. For instance, we could just go straight LLVM, and it will compile it, like the actual WASM, compile it down with LLVM so it's as efficient as possible. And even more, I don't know where it says it. Pretty much anywhere. Where is it? So it supports something called ahead of time compilation. Oh, there we go. This is the page I wanted. So yeah, cross compilation. So you can pre-compile it to essentially a binary on one platform, like an x86 binary, link, like just a .lib file essentially. And then you can bring that over to, like, say, Android, and then cross-compile that, which is a lot less expensive than, say, on a Quest, Brane. Come on, Brane. It's a lot less expensive to pre-compile a binary to a native format and then translate that native format from one to another instead of doing that compilation live on the device while you're running it. And from my understanding, that's something you can do with this library, which means I get all the speed stuff I wanted to do with my game engine and everything. but I don't have to write everything from scratch. I do have to use WebAssembly, which, you know, has ties to JavaScript, and I'm not a big fan of JavaScript. But I think I can live with it. And it is mainly a Rust library, and that's why we only have C-style bindings for it. But yeah, right now we're just using single passed, or it might even be an interpreter behind the scenes at the moment. I'm not sure. But yeah, so that's the research I did on the how to actually get a runtime working side. And then what we're doing on the Rust side is figuring out, okay, how do we make this a good user experience for somebody actually scripting in the game engine? Because I don't want people to have to write no mangle extern-c in front of all their functions. And I don't want to have to rely on this to actually find functions, because there might be a bunch of functions in a WASM binary, but we don't want to be able to call all of those as systems in the game engine. So I need a way to define which of these are actually systems in the game engine, aside from just extracting them from the binary natively. Which is where these two attributes come in. So Rust is super cool in that it lets you define compile time macros, called procedural macros in this case, attribute procedural macros. And they let you edit the actual token stream for whatever you put them over. So these macros can actually add the no mangle and extern C right in there. They're not yet, obviously, because I was focusing on something else I wanted them to do first. And that thing was create a script definition file. So using the TOML or TOML format, list out everything that has a component name, or list out all the components, what their names are, and here we could also store other attributes. Like, for instance, if we have something to do with the timing of a system and we wanted to put that in here, like we could say order after test function 2 or something like that. So if we wanted to do something like that, we wouldn't be able to extract that from a WASM binary. We would need, you know, a third-party store of data like this. What I wanted to do was store a different thing with a different name for each file. So test script here and test script 2 would have different TOML files associated with them. However, I ran into a pretty big roadblock there, and it's that we do have this file macro that Rust gives to us, but this only gives us, even in a macro, this still only gives us the current Rust file. So here it's getting filled out with macros.rs, which is why this is macros.rs.tml. And there's actually no way currently in stable Rust to grab the file name. You can in unstable Rust, so if I switched over to the nightly branch of Rust, we would be able to go ident. Why is it? I want to code here. It is broken. There we go. Ident span. And there's actually this source file function here, but it's only you can only call it on the nightly version of Rust, and I want to stick to stable Rust as much as possible. So, and that's basically the only way to grab the current file that this macro is working on. So the macros are no longer a solution for recording that data. So I'm moving on to a different solution that just last night I got a proof of concept working for it. Not much of a proof of concept, but for now I'm going to turn off the actual saving of files. So the only TOML files that will be appearing there are the ones that we generate from a build script. So this is a function that's run at the start of every build. So what a lot of people use this for is compiling C libraries that they want to link to their Rust project. So they'll call some CMake files from here, get that all compiled, and then that's able to be linked into their Rust project. What I'm going to be using it for is what I wanted to use the macros for. I'm still going to use the macros because they can edit the function or struct definition to be to actually show up in the WASM file, and later on do a little bit of a translation of types. Like a string type, WASM doesn't have a definition for that, so we'll need to do some funky bind gen stuff. But yeah, we won't be able to use it for recording where they are in files. So the way that we end up doing that is, I just realized these are getting compiled as the same compilation unit. What I actually want to do is, and this is how I think libraries are going to work, scripts are going to work in the game engine. Behind the scenes, we'll programmatically add each one of these as a library to a to like the root project of our game project, basically. So instead of test script, we'll go test script 2 wasm crate 2. So this should now show up as its own thing. Execution could not parse input as TOML. Duplicate lib. Rust crate. We might just have to add extra angle brackets around it. Multiple libraries in a cargo project. So we can have multiple executable targets, but only one library target. Okay, let's see, workspace. Oh, so instead of defining it as a package, we would define it as a workspace? And then we could have multiple packages. Does that mean I'd have to duplicate all of this? Like, dependencies and build dependencies as well? Okay, but you still need other TOML files? Because ideally what I want is every single script to be compiled to a different binary, so they're all separate and can be loaded in whatever order I need them to be loaded in. I mean, one of the things we could do is just call rest C manually, but that's not really something I want to do, because then I'd have to deal with all the build dependency stuff. Okay, so we can say workspace dependencies. Now we'll add it to the entire workspace. So all of this is really nice for making a project with Rust, but for using it as a scripting language and trying to semi-hide it in the background, it makes it a little bit harder if we want to use the stuff that's already there. But if we have to make a, well, my main thing is, can we have multiple libraries per directory? Multiple build targets, I guess. Say workspace, we say members test script 1 and test script 2. We'll say this one is test script. We don't need to worry about, we'll still use the build script. say workspace dot dependencies. Can you also say workspace build dependencies? Does it show up under... Well, Copilot pops it up, but not regular autocomplete. Okay, so I think build dependencies still has to be a per crate thing. I just thought you'd be able to define two libs because you're able to define multiple executables. So this throws a hitch into my plans. Okay, so what if test script 2 duplicate package and document root. So do I need a separate folder per system? Could you imagine if in Unity, every single time you created a script, you had to put that script in its own folder and everything? I mean, I guess it depends on how I end up wanting to implement scripting, because it's completely reasonable for me to allow, like, okay, let's take my own example here. We have two systems in a single file, and in an as a quick refresher, a system is something in an entity component system that acts on entities. So in essence, it's like almost like a mono behavior in that sense. If going with the example of Unity, I have considered Lua and LuaJIT. I looked into them. I'm just really not a fan of Lua and dynamic typing, so because of that, I actually spent a fair bit of time. Well, you probably know I spent a fair bit of time like writing my own scripting language from scratch. So in comparison to that, this is a lot easier to deal with. But yeah, I've messed around with FreeCAD a little bit in the past with the in different CAD systems and whatnot. There's one browser-based CAD software that I actually like a lot. I'm just forgetting the name of it, but there was this browser-based one that I loved a lot. Forgetting the name of it. Yeah, maybe I'll look into it next time I'm using CAD software again. It's been a while since I've used CAD software. It's back in my 3D printing days. I do want to get a 3D printer again, though. But yeah. Rationalizing this out, it makes sense that maybe we let people define multiple systems and components in the same compilation unit, and therefore also the same modular thing to download, because if we have a ton of really small scripts and they're downloading all of these separately, that might actually slow down download rather than having some sort of asynchronous system that speeds that up in the background. Because the idea with my game engine is that, of course, you can... Oh, hey! Hey, Shadow, how's it going? Yeah, right now we're just... I'm thinking of the implications of new information I've learned about the... how cargo works. And how I'm possibly going to be... Well, I pretty much decided I'm using it as the scripting system now. And we have a path to that. I just need to figure out the intricacies. So, far cry from building my own system. Now we just have to glue the pieces together. Yeah, so for the sake of argument, well, not argument, just to test this out, let's say test a script, or I wasn't. Last stream I was trying to directly compile it with LLVM. I've decided, upon doing a lot of research, I realized that WASM is probably the better bet. It'll probably be very close to the same amount of efficiency, especially if I go with Wasmer, which is the current thing I'm testing out, since they have ahead of time compilation and cross compilation, I think, for the ahead of time compiled binaries. So with something like that, I get the same amount of speed that I would theoretically get, especially with the LLVM backend for it. So using LLVM and everything, like, all right, this is basically what I'm looking for. Let's just use this instead of coding my own stuff. Though, funnily enough, when I did start coding the whole engine project and everything, Wasmer hadn't even gotten to version 1, so I'm going to use that as my excuse of why I didn't go with it in the first place. It has since reached a decent amount of maturity in the years I've been working on this project. test scripts 1. And in here, say test script 1, test script 2, delete all the package related stuff from here, through the build dependencies. Gameplay framework. What do you mean by gameplay framework? I do plan on providing a decent amount of utility libraries, and there will also be hopefully a usable API for interacting with the entity component system, because that's the entire point of having the scripting language. So I'm not sure what you mean by gameplay framework, but there will be pre-existing parts of gameplay that you can interact with, if that makes sense. So ways to interact with the rendering system, ways to interact with the networking system, ways to define your own stuff, all that good stuff. By gameplay framework, do you mean something more like, say in like VR chat, you use VR chat components, and when you load into a VR chat world, you're pretty sure you know what you're going to be getting into, whereas with something like a web Java game, you know, it could be anything. Is that more so what you're asking? If so, I do plan to have a little bit of that, but without guardrails. So if you want to just throw it at the window, you can, but there will be I guess you could call it a framework that you can build on top of. At least I'm planning. Oh yeah, no. All the stuff that I learned while making stuff from scratch has been incredibly valuable, even outside of like the this project. I need to fill up my water. We're running on empty. But it's been helpful in work and basically just how I think about coding as a whole. Okay, test scripts 1. Test scripts 2. Okay. So for each script asset, see, Unreal as a reference. Gameplay framework. Okay. So basically, the basics of the framework is like you have your most basic thing, which in this case would be an entity, and then on top of that, a couple other stuff. I will say this, it probably won't look a lot like the Unreal Engine framework of things. It's going to be a lot closer to how Unity works, just because that's what I'm more familiar with, and I don't like how this feels a little bit more restrictive, or whenever I've messed around with Unity, it's felt more restrictive than Unity does. It'll probably be its own thing, but there will be some elements of this, and I'm still figuring out everything. So we'll see how everything turns out in the end, because like in old update videos where I was talking about starting working on the scripting system, I did actually trash WebAssembly a little bit, and now here I am using it. So we'll see what happens. Oh, hey Cobb, in YouTube chat, when did I get 500 subs? I think within the last 2 hours, because right before I started the stream, I think I had 499 on YouTube. So it's like right now is the answer. Yeah, big moment. Woo! Past the 500K mark. You know, only a couple 100,000 to go. Okay, let's copy this terminal file over to here. My control key is glitching out and pressing itself multiple times. So I might need to buy a new keyboard. You know, I'm very, you know, devastated that I will have to make this purchase of a new keyboard. It's not like every single programmer yearns for the day where they have an excuse to buy a new one. Let's see. Just have this here. I guess I have to copy the build script over as well. Okay, if I do want to do stuff through a build script, I would need a workspace level build script. Okay, resolver, packages, excludes. Okay. So build scripts are still locked to an actual package, since I guess you can't have code outside of actual packages. Execution failed on test script 1 cargo. Oh, it's because I haven't edited. Wait, no, I edited this. I thought I did at least. Maybe I only edited number 2. Test script 1. Oh, we only did 2. Oh. 2, test script 2, Wasm crate 2. And then this one. Wasm crate 1. Test scripts. Test script 1, test script 2. Test script 1, test script 2. So it's still failing on something. Oh, it's because we have this build script. Wait, no. In test script 2 we have build. To read test script 1 cargo. Build. Oh. It's asking for the files, for the actual file name, not for the name of the package within the file. Okay, that makes a lot more sense. CMake include subdirectory. Failed to parse. Okay, so we need a version. Guess we need to put this in this as well. Proc macro 2, build RS. But I do have it as a build dependency. Great, and proc macro 2. Oh. Cargo. Cannot be found. I didn't spell it right? Oh, you're right. Yeah. Let's see. Right. Not be found in registry. I just can't spell. But this is in the build file. So it should be in build dependencies, right? Because I'm not using proc macro everywhere else. Yeah, that's just because. So it is the build script. Build dependencies. This was working before. And sub. Package.build. Right. That's what I'm thinking. It's just weird that maybe I have the build dependencies wrong. No, that's still spelled correctly. Unused import. Okay, so why is, well, let's see if it is working. Let's see, maybe I need to add it through command line to force it to work or something. Go add dev. Let's see. Options. Vision dev. Okay, so you can just say build. So if I say in here, cargo add proc macro 2. Let's see, it wants options before the crate. Okay. So this, oh wait, no, that doesn't work either. Oh, it's back to Marco instead of macro. And build. There we go. So that's it here. Cannot determine which package. Package test script 1. The dependencies are showing up here in cargo lock. Wait a second. Is it because I'm not on the build target? Like if I just said build scripts, this command's running against an actual package. Build target, wasm 32, unknown. Okay. We can work with this. Or at least we should be able to. So workspace dependencies, these should be inherited by child crates, right? Because they were working before. Oh, you just say so we still have to add workspace dependencies. I thought that this would just, like, you would just inherit everything. But nope, we still need to add dependencies. And we just say workspace equals true. Is true a, okay, yeah, it's just true. Of course it can be found. BraneEngine dot. Can I just say that? Oh. So that works now. So even though we're in a workspace, we still have to define which of our workspace dependencies we're actually using. This is going to add a lot more metadata for each compile target that we want to add to our project. Of course, I'll handle the configuration of all this stuff in the engine itself, so hopefully the users won't have to touch it too much. But it's still a little bit of a pain that this file will still be there. Okay, so this should be fine now. It's not. That's test script 2. So now we need to go over here. Just complaining. Even though we have proc macro 2, and this is definitely still the build script. Wait. No. Build goes under package, right? Okay. We have build script, wasm crate, wasm crate. Well, what if I just run this from the terminal? Still isn't resolving. Oh, it's not even importing BraneEngine. For test script 2. This is just not working at all. Editor is still smarter, it knows where this is. It's complaining first on this build script. Why does this not work? Let's put it under our root then. Which is not allowed. Can I say workspace dot build dependencies? I can say workspace build dependencies. So then can I say proc macro 2 workspace equals true? Like that. Space dependency. Oh, interesting. So even in build dependencies, it's still trying to inherit from dependencies. So maybe the solution is we drop this under here. That's still not working. Well, it's not technically something I need to do at specifically build time. Because we can generate I'm glad some of us are finding this useful. No. But I'm coming to realization, and that's that I don't necessarily... So what my build script was going to do was what I was originally trying to do with macros, but I ran into an issue with getting file names. But I have these component and system proc macros that I can put on functions to mark them as something I want to be able to call from the engine, and components as something that I want to be able to use in the entity component system. And what I wanted to do was have these do a little bit of bind gen stuff, right? Convert stuff like strings to stuff that's usable between both Rust and the whatever my backend is, which at the moment is C#, not C#, C++. So we need to do a little bit of custom bind gen there. So I wanted these components to do that. But on top of that, the other thing I wanted it to do was create a list of all of the components and systems, along with potentially in the future a little bit of metadata, especially for the components, because I don't know if we can actually extract... I don't think we can extract structs from the WebAssembly binary. We can for functions. For this, it's just we store the name of the function and then we can grab it out of the binary later. That's pretty easy. For components or structs, I wanted the attribute to go, look over all of the members, record some metadata about that, and then store all of this to something like a JSON or a TOML file. I was trying a TOML file first, and I wanted a separate TOML file per each one of these files. Now, it actually matters less now, because at the time I thought we could individually compile each one of these to their own separate thing, to their own WASM binary. Now I know only one library per cargo file. So it actually becomes less of a deal now. However, I still think that this is more of the right direction, where we scan the entire directory and just parse out the entire thing. The problem is I just can't get the build script to work. But it does make a little bit more sense to make this a part of the engine itself instead of a separated build script, and then we have to go grab the TOML file later. Instead, we could have this be a library that the code calls start. We can start mixing Rust and C#, not C#, C++. I've been doing too much Unity recently. Need to do more low-level stuff. This is like what we're doing to relax. So the reason why I want to separate them is the whole idea behind the way the game engine is architected is it's made out of assets, and the assets have dependencies on different things. It's very modular. So you have your chunk, which is a modular piece of the world. So instead of doing scenes like Unity does, I've decided to do something where you have, where the world is essentially constructed of modular chunks. So instead of a scene, you have a chunk, and that chunk can connect to other chunks, and you got your whole grid, or they won't be necessarily a grid. They'll be like custom, very simple mesh defines boundaries or something. I haven't figured it out totally. But you have chunks that connect to each other's. So the chunk is like the base unit of the first thing you ask for when you load into a scene. And then within that chunk, you have the scene graph. So that has all of the entities along with the components. So then that chunk will have a list of dependencies for all the assets containing the components that are on those entities. All of the models used within that chunk, all of the textures, all of the shaders, and each one of those is an individual asset, which the server then can runtime stream to the client, because the idea is that it's an asset streaming game engine. And with the switch to WebAssembly, I do plan to eventually build at least a trimmed down version of the client to the web browser as well. So dedicated client is best experience, but then you also could load up, say, a web browser client for the accessing the experience provided by the engine as well. So everything is streamed in. And that's why let's say you have a giant open world game, I wouldn't want to have all of the scripts in the entire game in one WASM target. I would want them to be split up. So in this section of the world, you only load in the WASM required for the AI for these enemies, or the WASM that controls this particular type of shop, instead of loading in the entirety of the world, because maybe you have a procedurally generated mesh for the ocean, but we're on top of a mountain. We have the procedural generation for trees instead. So you don't want to load in entire game, because I want to be able to support very large, complicated things, and only loading in the small portion of whatever world you're in. Right. And that's why I actually am willing to go a little bit more compartmentalized than one build target per script. Maybe it's less like each mono behavior, to use Unity as an example. Instead of having each mono behavior compiled to a different separate thing, maybe we go more of like the Unity assembly definitions, where it's actually controlled by the user how to compartmentalize their code, and that might make a little bit more sense. So we have, we have engine utilities for making it easier, but that probably makes more sense. Yeah. Right, what would I call this in the engine? Because my current name for the asset type that I have just blocked out in there, it's like an empty class placeholder for when I do eventually add it in scripting. What do we call the asset? Something along the line of behaviors. Like a behaviors asset? I could do package, but package implies stuff other than code, and there's different assets for other things. It would match with Rust. Maybe we just call it binaries. Though everything else is binary too, so it's like very general. What is a good name for specifically code assets that could be mixed up with any other asset. I mean, could go with assemblies, but that's just pulling it straight from... No, assemblies is what I'm calling my version of a prefab, so assemblies is already taken. Ooh. What's the name of that? What's the name of the brain chip from Cyberpunk? Well, I mean, they use assemblies in like the CAD world. In the CAD world, a prefab is called an assembly. It's not a completely new thing. Do they call it prefabs in Unreal? Maybe I do just call it a prefab. Okay, so it's not a Unity specific thing. It is a Godot, sorry. Godot solution. Nestable prefabs. Scenes. Oh, so Godot just loads a scene? Right. Okay, so Godot actually... So Godot saves prefabs they're just scenes. Oh, hey, Lucas! Lucas is on the YouTube chat. How's it going? I saw your podcast appearance. What was the name of the? Oh, dang it! Forgot the name of the. I went to the most recent YouTube podcast thing you did. It was pretty cool. Completely lost my train of thought. We were coming up with a good name for what we call a compiled group of scripts or whatever. And I just completely lost my train of thought. Yep. Have lost a little bit of steam recently just because work has been more demanding, but I have been trying to work on it like 1 or 2 hours a day still. And I'm going to try to pick back up streaming a little bit more often than I have, at least on weekends. At least one stream a weekend is kind of what I'm aiming for. But yeah, we're still trying to create something. Let's see. I think for now we'll call this a dang it. Nothing's coming to mind for a good placeholder even. Yeah, we'll just call it a package for now, mentally. Very generic name that's going to be confusing. But yeah, we'll call these packages for now. And it was gonna happen sooner or later, so we can just start figuring out the pipeline now. Let's add... We could do modules. I just feel like module is a little bit too generic. I like the feel of modules. I like the sound of modules better than packages. So we can go with modules, packages, a modular pack. No. Yeah. But we're getting too held up on just naming here. We need to actually get some work done. All I've done is break the project and not show you guys anything the entire stream. So what we're going to do is start committing the sin of mixing both C++ and Rust in the same project, like actually interfacing the two. Indeed, indeed. So we are going to name this So what it does is it extracts script metadata, or, sorry, module metadata. Module metadata parser? Yeah, let's go with parser for now. Actually, let's do this the correct fancy way. So you're gonna say open in terminal. Cargo new lib. Actually, can we say C dynamic lib? No, we probably just have to do that after the fact. Cargo new module metadata parser. And there we go. Let's we're gonna add a CMake lists to this. And what this is going to do is run a custom command that builds the cargo project. So our command is going to be cargo build then I always forget the inline conditionals format. Inline F. Let's see. It's called config. Ah, here we go. So what I think this is doing... Oh, come on, paste, there we go. So this is an if statement where, wait, no. Config, debug. Okay. So yeah, if this is debug, we don't want anything to be here. Actually, I'm pretty sure there's an if format for this. I remember doing a ton of research on how to use these. Nope, I want to keep that tab open. Right, generator expressions. There we go. If. Yes, there it is. So we just want this. If config debug, or sorry, release, then we want to do release. I believe that's the correct Rust command line stuff for that. We don't want to do current binary dir, we want to do current source dir. And then let's just see if that does what it says on the tin. What it says on the tin. I'm here creating old-timey expressions out of thin air. Or remembering them out of thin air? Add subdirectory BraneEngine API. No, not API. Module metadata parser. Like that. And then let's actually go to awesome scripting tests is the current build target we want to be working with. I didn't see anything. Oh, should probably. So I'm not seeing this doing anything, which is concerning. Is add subdirectory the correct thing? Okay, yeah, it is. Add subdirectory. Yep. Scripting, add subdirectory, module metadata parser. Can I tell it to echo the command? Not at the moment. I can actually include this in that string. So let's just building Rust library. Okay. Oh, there we go. We got an error, but it didn't format like an error, so we didn't see it. So unexpected argument. Oh, so it didn't even it didn't evaluate this. Okay. We'll do it the easy way for now. If debug. Just paste. I want you to paste. There we go. Here we go. There we go. Warning, should have a snake case name. Alright, I will follow the Rust conventions. Is it complaining about the file or the... Well, I should probably name the file too. And we will... Did it rename the CMake lists for me? It did. Very fancy. And here. Okay. Just checking to make sure it didn't, when I said add, it didn't include it somewhere else. Okay, we're good. So we automatically generate release and debug builds. Lib module metadata parser. Cool. Predictable name, predictable location. Perfect. this the debug file? Or data? All right. Let's just run this again, since we changed the name of the thing. Oh no, I don't want to do that. Building. Scripting module metadata parser. Is my file system just not updating? Reload. Oh, it's right there. I'm just blind. Wow. I should probably go get some water. Okay, so lib module metadata parser. This is what we need. Rlib. We need this to be a lib, and we could change the name. We don't need to. Create type? Yeah. The dynamic lib. Actually, we don't want it to be dynamic lib. Can we just say clib? Static lib. I believe that's what we want. That we can check. Runnable dynamic Rust library. Static library will be produced. This is different from other library outputs in that the compiler will never attempt to link static lib outputs. The purpose of this output type is to create a static library containing all of the local grids code along with all upstream dependencies. Okay, so that could be a very big binary. C dynamic lib, a dynamic system library will be produced. So we might want to do dynamic lib. 'Cause dynamic libraries can link to other libraries they need, because I could see with static lib, you know, we include the Rust standard library in every single library. Will never, system library will be produced. This is different from. We'll never try to link to static lib outputs. static library. It's an ambiguous concept as to what is actually produced because the library can manifest in several forms. Highly recommended. See, this is a DLL. This is .lib and .a. Actually, if we have two static libraries linked by the same project building an executable, will that compiler be smart enough to say, okay, these two different static libraries have redundant functions in them. Let's just use the functions from one of them. I honestly don't know. Two static libraries having redundant. While switches your chain don't include one library into another, they just enable functionality that requires those. Right, that's for dynamic libraries. I know it eliminates unused code, but what if two static libraries have the same code? Is it able to detect that and then merge? Because that's my main concern with this static library, because I like static linking stuff. Okay, so this is their recommended thing regardless. So we'll just go with static lib for now. It may increase our binary size, but that's not too big of an issue for now. I'm fine with having a larger binary size. It's just a little bit... I wanted to at least do some research on it to make sure we're not like extremely bloating our project. Alright, so static library. So if we delete target again, rerun CMake. Compiling this. In files. Yeah, targets there. There it is. I had to click in and out. Okay. Lib module metadata parser. So we now need to copy this over in do we need to copy it? I don't think we do. I was thinking we need to copy this into our actual build directory. But remembering how CMake works, you can just do add library module metadata parser. Add library module metadata parser. Static. Actually, no. This is going to be an interface. Target. Link libraries. Set lib name to be CMake current source directory. Target. In this case, debug. Then lib module. Module metadata parser. I think we don't need to include the file extension for this. And it will just pick whichever one makes the most sense. Because I know if it can't find a target with that name, it just adds lib onto the end of it and then searches for that in the current directory. So if we do this, it might automatically add a .a or .lib for us. Module metadata parser, click. Public lib name. Actually, a better name for this is libpath. So that takes care of compiling and linking our Rust library. Though I do want to make it so if that command fails, we do get a compiler. output. Echo error variable. Make command echo. Command error is fatal. Any. There we go. So now if Rust compilation fails, it fails. If it fails, it fails. If it dies, it dies. Now, the last thing that we need to worry about is how do I link our stuff? For now, we could go no mangle xturn C on everything manually, or we could use Rust BindGen and figure out how to get that all set up. And this generates Rust bindings for C and C++ libraries. And this is very similar to what we want to do for the game engine, so it's good to see it in action. In fact, I thought about maybe attempting to use this behind the scenes for the engine, but we don't need header files. What we need is metadata. And we can't use the existing WASM BindGen libraries because those create BindGen from WASM to JavaScript, and I don't want to touch JavaScript with a 10-foot pole. So we're going to create our own BindGen for that. But for now, for our actual libraries, which are, you know, my old 2 years old C++ project, we want to connect that up to the spicy new Rust portions of it. So that's what we're going to do. Which one is this? Let's actually just clear these out. And open up another here. Put it in terminal. So we are going to go cargo add. Just BindGen. I don't know, what's up with you? So I actually do very much enjoy C++, but, you know, we're dipping our toes in Rust for the scripting language for the game engine. So, you know, we're not discriminating, we're using both Rust and C++. Which some people may consider a sin. I consider it a challenge. So we already added it as a build dependency. So right now we're we're working on getting it linked up right now. So it's the core of the project is C++ using CMake as the build system. So what we do is we have a Rust crate inside the project structure of our actual project. And then I added a CMake lists in the same folder we have our cargo file in. And we just have CMake tell cargo to build the Rust project for us. And it builds, in this case I'm on Linux, so .a files. On Windows this would be lib files. And then we just create a CMake target for this so that our C++ code can link back to it. Right now we're working on the last step of the puzzle, which is the header files, so we can actually interact with it. And we're using BraneEngine for that, because people actually do want to do this on occasion. So we added BraneEngine. So we need to create a wrapper.h header. Oh. So does this include other header files? Yeah, so we're gonna have to do everything through extern C. So the way that you do it in Rust is you give it the no mangle attribute, and then you say this is extern C. So now this will be visible, but that's a little bit of a pain to do by hand. So we're gonna use a module to do all of this for us, and it will also handle stuff like strings and whatnot, or we'll be able to tell it how to handle things like strings for us. And it will also automatically generate the header on the C++ side. So instead we'll just do whatever their procedural macro is. What is their procedural macro? Oh, come on. Wait a second. Is this to go from C++ to Rust? That would explain why it was so hard for me to find, like, I thought this was to go between both of them. Let me look at the actual BraneEngine. Automatically creates bindings to C libraries. So Rust using C libraries. That makes a lot more sense. So we need to find a... Okay, so there's a C BraneEngine fold. Okay. We don't want BraneEngine. We want C BraneEngine. Okay, that actually I'm glad I found this because I was looking for a good crate that does something similar to this. To reverse engineer for my own systems. This is incredibly valuable. So yeah, we don't want to go from Rust to C++. The whole structure of that library makes a lot more sense now, because I was looking at the source code, and I'm like, this looks like it's trying to go from Rust to C++. Okay, that's cool. I know it's supposed to do that. Now, where's the code to go from Rust to C++? And it wasn't there. Okay, BindGen, go gone. Add C BindGen. Woo! There we go. This is a lot more usable. Now let's figure out how the hell it works. C++ 11 headers. Perfect. Ensure that the headers regenerate reflect actual guarantees about Rust type layout and API. Oh yeah, some more Rust-like API. To use as a standalone program or as a library. We're going to use it as a library. Why do you have to force it? Oh, so install, it's saying install so you can actually run it. We're gonna use a build. New Rust file, build, add. We're just gonna copy that. Let me paste. There we go. See BindGen, builder new with crate. The current crate. Write to file. We're gonna call this module metadata parser.h. Yeah. Extern crate C BindGen. Couldn't find crate. So in here, well, this has dependencies and build dependencies. Why are you complaining about proc macro? That's a different crate. Fine, we'll delete this for now. I have the version of it in source. Do I have the version of it in source code? We're gonna check this real fast. not brain script, we want BraneEngine branch. Wasm scripting tests. Source common scripting. Yeah. So I have the version of well, yep. Okay. Will you stop complaining now? It will. And it just generates it there in our project folder. Amazing. Okay. Do you actually want this to be in I think targeter is the correct place. We'll actually keep this, just say we'll just call it include for now. I don't want it in the root directory, but we don't necessarily need it in the target directory. And then in here we can say target include directories. Public include. Then we can rerun CMake. Oh. Interface. Forgot about that. Theoretically, this all works now. I'm gonna delete the target just so that we get the BindGen to run again, because I want the file to actually exist. All right, cool. So you now have a .h file. So now on our WASM scripting tests, if we link to library module metadata parser, we should be able to include here back in C++. Include module metadata parser. There it is. Now, how do I Okay, so we still have to do no mangle public extern on functions. So let's try out a simple example, then a structure, then something with vectors, and just see how it handles it. Pub extern. We don't have to say C, we just say extern. And then after that, yeah, let's just go with add. Let's call this Rust test. Module, metadata parser, no mangled public extern, and add. Now, and we'll, can you nest modules? Let me paste. There we go. I need to buy a new keyboard. All right. Rerun CMake. Look at that. Extern C. Add is not doing. I thought maybe the module would turn it into a namespace, but apparently not. Is there a way to do namespaces? What do you mean, what's wrong with the old one? I'm unsure which old one you are speaking of. Oh, it's because whenever I try to paste something, like either that will happen, or... Well, basically, in this code editor, if you double-click Control, you get this Run Anything window. And the problem I've been having is when I just go to Control Paste, a good 30% of the time, this window will pop up and I'll accidentally paste into it because my Control key is bugging. Now, I could just replace only the switch, but why would I do that when it gives me an excuse to buy a new keyboard? Okay, so this was represented. So this was... Okay. So that wasn't a macro for the BraneEngine crate. That was a macro just for Rust itself. I don't know, man, maybe. Okay, so these work. How does it do enums with fields? I am really interested in how that works. With fields? Maybe I'm confused on, like, the terminology here, but if we say no mangle pub extern test enum, and we say pub enum test enum, this I can see working. But what about enums with what I'm assuming it's calling fields? This is true. So maybe it just uses that behind the scenes? I don't know. Let's see what it generates for this. Test enum. Oh. It creates an opaque definition for it. So we can pass it in and out of C, but it's expecting us to just not touch it from the C++ side. Just, we can take a pointer to it. We can pass that pointer around. What is it? Who knows? Actually, this explains, so for the Wasm runtime that I'm using, it has a C-style, it has a C-style interface on it. But it's super weird in that you never interact with the you actually never interact with the types through the types. You call functions that interact with the types. So, you know, new module, that makes sense, right? You got module, but to get out the exports from the module, you know, you get an out export types. That still makes maybe a little bit of sense. That could be justified. But to get the export type of a definition, or the name of a definition, or the kind of the definition, you don't ever interact with the members of these. It's all just very, like, there's like some comments in here too, so maybe it's not completely auto-generated, but it follows that same pattern of, this is probably an enum behind the scenes. Like, it probably is an enum. A Rust enum with fields. Okay. So what if I was nice to the linker? Or BraneEngine creator. And I didn't put any fields on here. Would it generate a C# style enumerator? It still would not. It's still a struct. Oh, that's hilarious. So we can pass function pointers. Oh yeah, it's definitely too definitely too smart for C++. Though, oh man, I wish when I was writing all of my parser stuff I had been writing in Rust, because the enum system in Rust works so much better for that sort of thing than the junk you have to deal with in C. But yeah. So, whenever we try to use an enumerator, it's just like, okay, it's an opaque struct, man. Don't look at me. You're technically passing data. Alright. So we can pass just... does it have to be a sized array? Does it have to be a sized array? Structs, enums, unions, and type aliases may be generic, although certain generic substitutions may fail to resolve under certain configurations. In C mode, generics are resolved through monomorphization and mangling, while in C++ mode, generics are solved with templates. C BraneEngine cannot support generic functions as they do not have a single defined symbol. Well, that, yeah. BraneEngine can never support anonymous tuples. That makes sense. Maybe. Though I think most people are pretty happy with just switch statements. If we're talking about the same pattern matching. So I can't really see them copying Rust, because if C++ starts copying Rust, then what's the point of using C++? Just use Rust. Contains the following hard-coded mappings. Phantom data evaporates. libc types. Okay. Standard int types. Target language, styling, mangling, prefixes, includes, and defines. Okay. Ignore any test item it finds. Cool. Enumerators. It might be. I haven't really kept up to date. Let's see. Let's go down the rabbit hole. Pattern matching is an alternative to using if statements to... Oh, so it's already in C++? I have never seen a match statement anywhere. It's very similar to the Rust match statement. I can tell you that. (2021). Wait a second. Oh wait, when did this come out? 2017? They have a whole tutorial on it. Oh, it's for this guy's specific pattern matching library, where I'm guessing this creates a callable object. This is a function that creates a callable object, and then you call it. Oh, is it a variable argument function? And each one of these patterns is... Oh, that's... Ugh. I mean, I guess it technically does the job. So if you're willing to use some super jank libraries, yes, you can do pattern matching in C++. All right. Okay, I'm not too worried about sending enums back and forth. What I am mostly worried about is lists or arrays or those. So one thing I should probably look into is builder. What methods do we have? Fig header includes add a pragma once guard. This should be true by default, shouldn't it? Language. So how do I say that this is with create, expect, write to file? Okay. With C++ be compatible, true. We do want to be compatible with C++. See what other things. Oh, come on. I want the editor. Not you, Copilot. There we go. Ooh, with documentation. It just makes writing tests easier. With namespace. Can I do that? And we'll just... Ah, yes. Glorious day when it does. Okay, yeah. So I can put all of this in a namespace. Good, I was wondering about that. So we now are using C++. If array length is not specified. Okay, yeah, let's just see what returning a slice would look like. Because that's an actual use case I have. Test enum. See, let's test a slice, and we're gonna return I32. Don't want any specified length. Can you return just without any specified length? The return type of function must have a statically known size. Dang it. Oh, wait. What about put? And we can have this be an I32 slice? No, we can't. Cannot be known at compilation time. I am newer to Rust, so that's why I'm figuring this stuff out. Though, is it the no mingle making it so that this has to be sized? Because I feel like I've seen being able to... Oh, can include string. Okay. Because, yeah, I know most of the time you want that to have a compile time size. And even in C++, you need to have compile time sizes a lot of the time as well. how does it act if we try passing a vector? Wait a second. Okay, yeah. It's... Consider using a raw pointer instead. Yeah. So that, yeah, it's references that can be unsized. Okay, vector I32. I wonder if it can automatically turn this into a C++ vector. That's like one of, if it can, amazing. Would you look at the, oh. It's opaque. It's opaque. Dang it. So any types that I would want to work between the two, I would have to manually define. Then again, string. String is such a common use case. Let's see how string works. Nope, opaque. Yup. It says, you're on your own. We'll create the header files for you, but that's it. I mean, for my own custom types that I tell to have a CABI like layout. Okay, so these are the standard types, all of which are just the most basic types. I had my hopes up because I knew that the bind gen for WebAssembly was a lot more config. It would be a lot of copying of data, this is true. Trivially undefined. Okay. But look at this. System includes string. J and I. It's not ringing any immediate bells. Sys includes string. So if it includes string, would it have a with include? This include include string. If I do that, I have not. This is my first time really trying to do a lot of interfacing between two languages in a bigger project. I have built an entire scripting language from scratch, but the meshing together of things at compile time is something that I have not put too much effort into in the past. Having an API that returns a function pointer, easy. And system includes string. So yeah, we include string. It's still not, yeah. Extern C block. Okay, so it generates. Okay, yeah. Oh, you can actually have it rename fields to whatever format you like. That's actually really nice. Let's try that. Oh, is it not showing up? Yeah. We would actually have to use the config for that. Okay, so there's nothing in here about specifically making it easier to deal with stuff. It really just generates the header file and then leaves you with that. So how did WASM deal with lists? Sorry, WASMer. Array vector. Says a size and a pointer to the data. Then when I iterated over stuff, I would just go data I. All right. So WASMer is the WebAssembly runtime that I'm going to be using to actually load the scripts and then run them. And it is originally built in Rust, and this is all being called from C++. So that's why I'm looking at their C bindings to see how they wrote them, because it's very similar to what this is generating, and this is making a lot more sense now. Seeing how that works. So WASMer is the actual, like, loads the WebAssembly binary. It can do ahead of time compilation on it, cross compilation of the ahead of time compiled binaries. Lots of cool stuff that we want to use. As opposed to me writing my own scripting language in LLVM and then distributing LLVM code over the network and then loading it raw. So it's probably a little bit more secure too than previous techniques I was going with for scripting. Okay. So what we're going to do So the source that I'm getting the WASM bytecode is from Rust. So these test WASM scripts down here, what they actually output to WebAssembly. So you can see I have my WASM crate down here. Well, here's the thing. WebAssembly, its whole thing is it's supposed to be as near native performance as possible. And one of the things that WASMer supports is actually just fully compiling the WebAssembly bytecode, or like JIT compiling and ahead of time compiling. Ahead of time is what I'm more interested in, but it can compile that down to like a .lib, so it's native bytecode, and then just call that behind the scenes like a regular function in machine code. So not interpreted, hopefully like just as close as you can reasonably get to native performance with a dynamically loaded script. And that is one of the requirements for my engine, is that at the compile time of the client, it does not have access to the scripts. So it does need to be able to dynamically load them. And through my lots of research, this is the best way. How big is the JIT? That is the That is a good question. So, actually, I think it's right here. So the WebAssembly binary, or the JIT, I'm not sure if I'm going to... So I'll definitely have the WebAssembly binary on the server that provides games and whatnot, because I do eventually want to have a WebAssembly based browser client, but for native clients it would probably provide the ahead of time compiled binary. But like there are several different backends you can use for it. Like single pass is like, it works. Crane lift, it's about in between with a little bit of optimization, and then you just have straight up LLVM. So that's what you would be using in production. So a little bit of load time if you're just loading directly from WebAssembly. But then, you know, that's how you get the JIT compilation and to native code compilation, is because, you know, it's fucking LLVM. In this case, it would be shipped with it, I think. I mean, maybe you could link to it, but ideally, this would only be on my editor binary. So there are like several different build targets in the whole project. I have my editor build target, I have a server build target, possibly 2 server build targets in the future, one for providing assets, one for actually being the network backend, like the runtime of the actual game for networking players. So one for providing assets, one for players, and then you have the actual client. And hopefully the client and the servers would only need one of these, and then we would use this to optimize and AOT compile binaries before shipping those to the people who are using them. Ideally. That's like ideal. Hope it works that way. We'll see. We'll just deal with it if it doesn't. But in the end, yeah, because for a browser version of the client, obviously we would just ship the WebAssembly binaries and then the browser would JIT compile stuff. But for actual client, I mean, if the client has embedded LLVM, I mean, we can probably dynamically link it. But if it does have embedded, it's not the end of the world. It'll just take a little bit to download. It would take quite a bit to download. I mean, not as long as building it from source, which is a pain. And I've literally had streams where, like, my computer's crashing as I'm trying to compile all of the LLVM libraries from source. And yeah. But for now, what we are going to do is BraneEngine source common scripting, then in here, let's actually write out a test. I actually have tried, well, I haven't tried C++ JIT. They do have a JIT backend that I've used a fair bit, and it works pretty well. I used it for JIT compiling a custom scripting language. Here's what we're going to do. So we have syn or syn, however you want to pronounce it, and we can use this to parse Rust files. I'm going to copy this main function and thank goodness we can just use print line instead of having to deal with the stuff we would have to deal with in a build script where warnings are the only things that print. Strange that it's not finding definitions for those. So for now, we'll just have this print out. What should we... Okay, we'll just call this build module metadata. And eventually we'll have this return a struct with the actual module metadata. But for now we'll just have it parse stuff out. And we don't need, well, let's do the, just have good hygiene. We'll have a module. The true question is, oh, that's interesting. Does use only work if it's within the module? Oh, it does. That's super interesting. Why is sin? So in the original build script, is it this 2 tokens namespace? Not using parse macro input because we're not a macro. Yeah, syn parse file. And we have SYN here. The fact that we're static lib shouldn't matter, right? Great time. Maybe it was just complaining because other stuff wasn't compiling. No, that's still broken. Okay, why is the library different? What's the difference between this one and that one? I'm not seeing any differences. Does it only activate itself for build scripts or something weird like that? So if I go to if I did that, could use SYN or just an SYN file. That's not what we want. On parse file. But it's not showing up.
We don't need visit, we just need parsing, printing, full. We definitely need full. think that's one of the things we were missing. Might be all we need for now. Oh, so it was literally that the default on parse feature of the package wasn't on for some reason. Okay. 2 token stream. I think that's the drive that we didn't enable. Oh, box. So weird because I can go to it there. It's a box. Forgot. Reminding myself the correct way to deal with boxes. All I can say is that code worked before. Let's... Oh, wait. Okay. Build module, metadata parser. So it's still not finding item. Interesting. I'm just gonna delete target. Still could not find item. Parse file, even though it's right there. Look, editor can even navigate to the symbols. What is issue? Due to the same issues. Seriously, what's the difference between this one? Which I guess it's a build script, but that shouldn't really matter. for some reason the feature was only being enabled in the editor. So weird, because when I set the dependencies manually, I actually am, like, from the very beginning, 2 years ago, a lot of my ideas were heavily inspired by the VR platform Neos. They actually have a 3D node scripting system, which I thought was awesome. Now, I'm probably not going to do a 3D scripting system right off the bat, but something like a 2D node graph system, I'm probably going to have from the beginning, actually. Because in entity component systems, an important feature of it is making sure you get the timing of systems correct. So in Unity, you put like attributes above like the script or whatever, so square brackets, order before, order after. But well, yes, it's not too intuitive, right? So my current plan is, even before a node scripting system, the way that you set up the order of dependencies of scripts in my engine is going to be, obviously you have your script files where you write out the scripts and everything. We have the system we're working on now where it will extract what systems you have, and then when you're actually saying, okay, I want to use this system somewhere, there will be a node editor for ordering them. So you say this system, then after this system, these two systems are dependent upon this system finishing. That way we can also support multi-threading and whatnot. So even from the beginning, I'm going to have a node editor in there, and it would just be still a big step, but smaller step to add a full node editing system into there. I think what it would do is still generate text on the back end. It would just be a front end that then like converts the nodes into a script behind the scenes. But I can also see a system like, we already have the system for extracting functions lexically from our files, so why not be able to make it so the node scripting system can also take functions from scripts and whatnot and be able to use that in the node editor. So yes, eventually planned, not right away, and elements of it relatively soon. I need to get the package manager to work first, though. Features full. 4 errors. Okay, what if we just get rid of those two because they're only causing issues for the moment? We did that. Is it not complaining anymore? Except anything but this? Yeah. The problem with a lot of entity component stuff in Unity is just Unity isn't an entity component system game engine. Yeah, I think it's mostly the stuff that people are used to and how abstract it stays a lot of the time. I feel a lot about it. A lot of how hard it is about the framing of it. Yeah, it's still hard. It's still hard, but I feel like there are things that can be done to make it a better experience for people. Mostly needs, especially in Unity's case, they need a lot more debug tools. Create 2 token. Oh, this is the using that I had. I should probably not be using that, but hey. So for some reason, the other crates in the project were causing this to not register as... Oh. It's fine. It's fine. We're good. Yep. I'm not gonna question it. Okay. So we now have this actually working. We're gonna no mangle extra in this. So let's try calling build module. Oh. I want to be able to pass in the file directory here. Not FFI save. I have to do char pointer or char slice. Let's see. So now we come to how do we pass a string? Oh joy, we got a 7 ways article. Alright, one pointer. Okay. So can we say FFI? Oh. So there's a... Is this in our crate? Or is this core rust? Okay, that's core rust. Cool. Extern uses standard FFI C string, uses type C string, which is not FFI safe. Oh, that's amazing. Okay, but that aside, does it actually work? It doesn't. Okay. So do we put pointer on this side? Okay, we do. buff. No, we want. So I think this is what we want to do. Why is that a uint? Why is it a uint? Not a char pointer. Not smart enough to do pointers? Because if it's not even smart enough to be able to do a pointer, I feel like there's a flag you can set for bind gen. Where is it? Oh, if I say reference, will this do a pointer? Oh, it's still a UN32. I do char pointer? Because they said... There we go. Well, that's just a regular character. It needs to be a pointer, though. Conan's bugging out. Const or mutable? Okay, there we go. Huzzah! We're actually able to transfer data between Rust and C, and by extension C++. So now in Wasm's scripting tests, let's module metadata parser, build module metadata. It would be nicer if this could be const. Why is from rock and why does it need to be mutable? What about C string? From pointer? What is my string? Oh, const char. Okay, so we want from pointer. This is it safe? It is not safe. Got my hopes up. And that should make it so this is const. Okay, good. because we do want to preserve const when possible. And look at that. We're now calling a Rust function, or theoretically we are. Okay, so they didn't automatically add the extension. Which means... Oh, there... I didn't think there would actually be a suffix. Or... I didn't... What? CMake, why is there a variable for this? Let's just make sure this is actually... Does it have the dot or not? CMake static library suffix. Okay, yeah, it does have the period. So I literally just pop this variable right here and right here. It's literally that easy. Interface. Okay, so if I want to do multiple Rust libraries, I'm going to have to compile them as dynamic libraries. And then we are also going to have to, in here, CMake runtime output directory. Okay, so shared, not dynamic. I guess we'll do this for the prefix as well. Right, cool. Let's check real fast. WASM tests. So we need to make okay, so that actually works. Oh, it's right there, and I'm just blind. Huh. Code worked on the first try. I just didn't realize it did. Okay. So we now have don't try to show me that. There we go. So now would you look at that? Found no script definitions, but we are running Rust code from C++. Because these two print statements are from Rust. And we have to do dynamic libraries. This brings me pain. You know, I bet I know what the duplicate Rust runtime stuff was from. It's probably from Wasmer, because I think we're statically linking to that. And that has all the Rust core libraries in it. Pain, suffering, agony even. But yeah, if we, let's just copy test script 1 in here. And let's throw that in our wasm tests folder in our, no, I want to, there we go. And if we run this again, we should see, oh, I forgot to add. I do much prefer static linking. It's just, I want to static link all the Rust stuff, but I can't because the Rust stuff all static links everything. I am barred from static linking by the enthusiastic static linking. Truly cursed. But anyway, yeah, look at that. We found a component. It's able to detect that it actually is a component because it can parse out the attributes. And if I remove this and we run this again, you'll see it says component is false. There we go. That's what I was trying to show you guys in the build script like 2.5 hours ago? More than 2.5 hours ago. But the build script wasn't working. So, yeah. We have two systems in here. So one, we'll have attributes here that will change our function definitions to make them work nicely with no mangle and extern, and just throwing that all on there at runtime. And we will do a better job of replacing types than cbindgen does, because cbindgen does not do anything, and for a game engine we need much better bindgen than that is providing us with. So most of our work is going to be going into that. It's not going to be too hard, I think. The hardest part is going to be figuring out a the hardest part is just going to be figuring out a pattern and then automating that pattern. And what I think we're going to do is we can make this macro search through all of the types that we're using in here. For basic types, it just leaves them. For more complex types, like let's say we have a string in here. And we have, we just call it text for now, why not? And our bindgen system will go in here and go, okay, this is a string. So we have some sort of map of all the different things. And it adds in like an unsafe block right here. We say let text, and we set the mutability of this variable based on whether this is variable or not. And what we do is we say text is equal to, and this will probably change this into like a char pointer, which can be mutable or immutable. Probably not a straight up character pointer. We'll probably have an intermediate string type, so let's say BraneEngine string. So this is our behind the scenes type. Maybe we'll even call it like BraneEngine FFI string. And then we prefix this, we like mangle it a little and call it text bind gen 1 or something like that. And then we have some conversion that happens here. And we just have this procedural macro fill out all this stuff. So from the user's perspective, they can still just call their text attribute they defined here. But behind the scenes, we're replacing it with pointers. Or even integer 32s, because I don't think WASM has a pointer type. So it doesn't have a native pointer type in the same way that assembly code doesn't have a pointer type. You just use the integer type as a memory address. So I just don't know if we compiled this to WebAssembly, would it just convert this into an integer 32? Or 64, depending, well, WASM 32-bit unknown is the build target we're using, so it was probably 32. So if we pass a pointer into WebAssembly, it's just, that's the main thing I'm worried about is, do I have to explicitly say this is an int 32 since that's technically what it is behind the scenes? Yeah, that's what I'm saying. I just don't know if the system is smart enough to tell, oh, it's a pointer, but it's actually a 32-bit. Yeah. I'm thinking of minutia that would take like an hour to debug at the worst. But yeah. So we'll probably do this bind gen stuff behind the scenes, throw a fancy error if we don't know what the type is. Can just throw an error like unknown type or insert type here is not supported as a system input or something like that. So I'll probably manually bind gen stuff like convert types. Or maybe I will create my own utilities, to be honest. Yeah. Yeah. WebAssembly is just assembly, but platform independent. More so than regular assembly. Because we can't have anything processor dependent in there. So yeah, that's my plan. This becomes a much nicer BraneEngine. And it'll be a lot easier since we know both the endpoint and the start point. Unlike this BraneEngine, where it's like, okay, when you say string, do you want to convert that to a standard string on the other end? Like, there's a lot of stuff that C BraneEngine just doesn't know how to deal with. And if I do end up writing a lot of this utility, I might actually do a few pull requests to C BraneEngine. Just so that I can have that type replacement utility in there. Bam. I think that's where we're going to end the stream there. Getting that linking working was a pretty decent stopping point. We're nearly at 1 a.m. here. So I should probably go to sleep. I might stream again tomorrow. We'll see. I do have D&D later in the day, so I won't be able to go forever. But if I start streaming early, we'll see. But yeah, thanks to everybody who's stuck around. I'll see you guys next time.